In this busy world, everyone seems rushing for work. Technology is being used in almost every aspect of life. But since coronavirus, everything is shifted online and people started working from home, which increased the use of technology in today's world, raising the issue of data security, which leads to the topic hacking. Most of the people are highly interested in knowing more about hacking and how it works. So if you are one of them, you are in the right place. Whenever you hear the word hacking, it seems to be a very complex systematic procedure to retrieve data that is confidential or, to be precise, out of reach. In movies, you must have seen hackers who are on their computers trying to retrieve passwords to unlock a door or control an elevator. After watching all that, mostly people wonder how do they do that? What did they do on their computers that let them have the control over a certain area? It is just having access to memory locations. First, let us define what hacking is. It is to retrieve confidential data by using malicious code. The data can be a password or can be used to control different sections like door locks or security alarms. In order to understand how hacking works, let's start from the basics. Bit is the smallest basic unit of information in computers. It has two states, on, that is 1, or off, that is 0. A bit can store one of these states. Collection of 8 bits is called 1 byte. The terms we often use, like kilobytes, megabytes and gigabytes, are sequence of bytes actually. Computer stores data in form of bytes. Your data is actually a sequence of zeros and ones. It is the language that computer understands. However, there are more number systems in which data can be stored. There are 4 number systems: binary number system, decimal number system, octal number system, and hexadecimal number system. Binary number system has 2 symbols, 0 and 1. It is also called as base 2 number system. Decimal number system has 10 symbols. It ranges from 0 to 9. It is known as base 10 number system. Octal number system contains 8 symbols. It ranges from 0 to 7. It is also known as base 8 number system. And the hexadecimal number system contains 16 symbols. It ranges from 1 to 9 and from A to F. It is also known as base 16 number system. Different machines uses different number systems to store data. But most of the computers use binary number system to store the main data, while other number systems are also used for various purposes. One example that is relevant to our topic, hacking, is the use of hexadecimal number system. Memory addresses stored in computer systems are in hexadecimal number system. If you want to retrieve data from a specific memory location, you can provide the hexadecimal memory address for that location, and not only retrieve that information using command line, but you can also change its data component if it is not restricted by the system. Before we begin to dive in the details of hacking, let's do some basic conversions that are used in these procedures. We will convert some binary numbers to hexadecimal number system. For conversion of groups of 4 bits starting from the right side. After that, we write the value equivalent to each group. Hexadecimal numbers are represented by adding 0x in the beginning, like 0xAC82. The values we wrote are obtained through this table. First, we write the decimal equivalents of these binary values. Then we write their hexadecimal equivalent values. How are these values in this table obtained? Let's see. For 1010 base 2, meaning it is in binary, we first split each bit and multiply it by 2. Then we add powers to these 2's starting from the right in ascending order and solve. The answer we get is 10, but it is in decimal. So we need to convert it in hexadecimal by using that table. And we came to know that the value of 10 in decimal is equivalent to A in hexadecimal. Now that you have a good idea of how to convert binary to hexadecimal system, let's focus on the interesting stuff. You know now that the memory addresses are stored in hexadecimal system, and you know how to convert binary numbers to hexadecimal system. Let's play with this data and see that what can we do with this tiny information. In computers, to perform a certain task, people write programs in different programming languages. These codes are executed line by line. Moreover, each line has an address that too is in hexadecimal. So the program starts from the main. As the code is executed line by line, after the main, the next line will be executed, which is calling a function called sum. After the call function, the program control shifts to the sum function. Whenever a function is called, a new stack is made. Stack is a data type that uses last in first out or first in last out, known as LIFO or FILO format, to store and retrieve data. In this existing stack, 3 elements A, B and C are already present. If I add a new element, that is D, it will be added on the top. And if I want to remove an element, it will also be D because it is added at last. Hence following the last in first out format or LIFO format. The last element entered is known as top of the stack. Whenever we call a function, it creates a new stack, and it also contains the return address of the function. It also has some reserved space that is known as padding. When we use the call function like we did for calling sum, our return address is stored in the stack. This is the address of the line very next to the call function. That is the end of the program. The sum program asks the user to give 2 inputs x and y. And the padding is actually to save this return address from overwriting. If in case someone gives a large value that can overflow the buffer, then this padding saves the return address to be overwritten. The user gives the input of x equals 5 and the second input is for y. Now if we give a relatively larger value for this input of y, we can overwrite the padding as well as the return address. If we overwrite this return address, we can return to any location that we want. All you need to do is calculate the return address that you want to go and add it to your input in a specific format such that when it overwrites this entire data, the return address is overwritten exactly by that address. Hence, you can jump using the return statement already present in stack by changing the return address to whatever location you want. This location can contain sensitive data such as password or some access codes. Now you see that padding is overwritten and return address is modified. This technique is called buffer overflow. What we do is we overwrite the existing data and use that to gain access to some location that is restricted by the system. This is a very basic level of hacking. This technique works only for programs that require input from user. Computer science students study this part in their early semesters, calling this process as buffer overflow, as this is one of the simplest techniques of hacking. Actual systems involve many checks to avoid this kind of hacking, such as using canaries and system locks that identify if your return address is being modified or not. If yes, then it stops you from accessing the data or simply kicks you out of the system. So actual hacking is actually difficult than this one. But this technique gives you an overview of how hacking works. Now you all know basic level of hacking. I hope you enjoyed this video and learned something new. Stay safe, stay home.